Hey all, welcome to homeschool and welcome to the second part of chemical bonding, right? In the previous video, we have discussed everything about the introduction, like what do you mean by a chemical bond, how it is formed, why a chemical bond has to be formed, when do you call some molecule or an element is stable, right? And we discussed about the ionic bond also, the definition of ionic bond, how an ionic bond is formed, right? What do you mean by ions like cation, anion, right? Electrostatic force of attraction and everything. And in today's video, let us try to discuss about some examples of ionic compound, like the formation of those ionic compound. Okay, so first and foremost, let us discuss about first one. Let us talk about structure and formation of sodium chloride. Sodium chloride. So a well-known chemical compound. So what is its formula? NaCl. So it is one basic example for ionic compound, and let us see how this NaCl can be formed, right? So in case of NaCl, right? So you have a sodium which belongs to a category called metal, and this chlorine belongs to a category called non-metal. Clear? And in the previous class, I told you that metals always loses electron. And non-metal always gains electron, isn't it? So now let us discuss how this guy sodium loses an electron. See here, try to understand one point here. No atom or element simply loses electrons. Only when it comes near with another atom, then it will try to lose the electron. Clear? Say when sodium is present single without any reaction, when no element comes near to it, it doesn't lose electron. When it is ready for a chemical reaction, when it will get ready for a chemical reaction? When another element comes near to it. If this is a sodium, say if nothing is there around it, it's single, then that point of time it will not lose electron, guys. But when something is coming near to it, and that something, if it is a non-metal, okay, then sodium tries to understand, oh, time has come for me to attain stability. I can lose my electron. Somebody is there to take that electron. This is how it thinks, and it will lose the electron. And that somebody who is there, which is a non-metal, will take the electron from metal, that is sodium. Right? See, when the conditions are favorable, only then a metal loses electron and a non-metal gains an electron. Yeah, fine. And now let us see the formation of sodium cation. Because it's a metal, it loses an electron, isn't it? So the very first step, here you have to indicate, see our sodium is there, electronic configuration 1s2, 2s2, 2p6, 3s1, isn't it? 2, 8, 1, unstable. So it will try to lose this particular electron. So how do you show that losing thing? One electron it will lose and it will become Na plus. We call it as sodium cation. We call it as sodium cation. And what is its electronic configuration? 2, 8, right? Which is similar to neon. Yes or no? Neon's electronic configuration is 2, 8 only. Right? So it is attaining noble gas electronic configuration. So Na plus C is the most stable one compared to single Na, neutral Na. Clear everybody? So this is how sodium loses one electron and it will become sodium cation. It has become sodium cation. So in the next step, what happens is, let us check it out with our non-metal. So non-metal always gains an electron, right? So who is a non-metal here? Chlorine. So what is its electronic configuration? Atomic number 17, guys. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5, isn't it? So I can also write it as 2, 8, 7. Is it stable? Never. Because you see, in the last shell, in the valence shell, you have the 7 electrons. If it can get 1 electron, it is enough for this chlorine to get stability, right? So definitely, whatever the sodium has lost the electron, that electron is gained by chlorine, and our chlorine becomes Cl minus. So anion, chlorine anion is formed. Now this anion's electronic configuration is 2, 8, 1 electron. If you add to this guy, what it becomes? 2, 8, 8 I can write. So this electronic configuration is similar to which noble gas? It is similar to noble gas called argon, right? Now Cl minus is the most stable form compared to single Cl. Clear everybody? So now you have Na plus and Cl minus. So in the third step, what happens is your Na plus combines with Cl minus, you would get an ionic compound NaCl. Okay, so this is what your stable ionic compound. Stable ionic compound. So here Na has a charge, positive charge, negative charge. Okay, so this is what we call electrostatic force of attraction. Static force of attraction. So what do you mean by electrostatic force of attraction? An attraction between one positive and negative ion is called electrostatic force of attraction. So that attraction is keeping sodium and chlorine together. So you are getting an entirely new compound called NaCl, that is sodium chloride. Here everybody? So this is how NaCl formation takes place. And now the very important thing in your syllabus is representation of a dot structure. So how do you write the dot structure? Dot structure of formation of NaCl. What do you mean by dot structure? See guys, dot structure is very simple. See here, if I have to write the dot structure of sodium, how do I write? Sodium. We have to write its symbol, that is Na. And if you know its electronic configuration, see where is sodium? Sodium is here. Which is the last shell? Third shell. In the last shell, that is the valence shell. Last shell is also called as valence shell, isn't it? So in the last shell, check it out, how many electrons are there? 1, isn't it? So I will put 1 dot. Now this becomes a dot structure for sodium. This is the dot structure of sodium, guys. Got to know? So this is how we write the dot structure for elements or atoms. Say if I have to write the dot structure for chlorine, how do I write? Just what is the symbol for chlorine? Cl. And check it out, how many valence electrons are there in chlorine? See, third shell is this one, right? Third shell is this one. So 5 plus 2, that is 7 electrons are there in a last shell. So you have to put the 7 dots. How many dots? 7. So put the dots in a pair, guys. So 1, 2, 3, 4, 5, 6, 7. Like this. So this is how we put the 7 dots. This is the dot structure of chlorine. So now let us check it out how to represent dot structure for the formation of NaCl. Yeah. So we all know the dot structure of Na, isn't it? So write down that Na and one dot above the symbol. And the dot structure of Cl also we all know, right? So Cl, what's the dot structure? 1, 2, 3, 4, 5, 6 and 7, right? So what happens here is an electron is transferring from sodium to chlorine. Okay, show that transfer of electron with the help of arrow mark, right? That's it. And after that, just write the formula Na. It has lost its electron, right? So after losing, it has got positive charge. So Na plus, you put it. And later Cl actually gained an electron, right? Show all the electrons. 1, 2, 3, 4, 5, 6 and 7, 8. Right? And after gaining one electron, this has got minus sign. You are indicating only the last electrons in the dot structure. The last electron of sodium has lost. It has lost to chlorine, right? So you are not indicating any dots on sodium. After losing one electron, it has converted into Na plus, isn't it? And Cl, last electrons are 7 already there. 8th electron it got from sodium. So you are indicating the last electrons. Chlorine has last electrons, so you are indicating them in the dot structure of NaCl, right? So this is what our NaCl, right? The dot structure. So this is a way of representing the formation of NaCl with the help of dot structure. So in a similar way, let us talk about the other examples like calcium oxide and magnesium chloride also. See, coming to the formation and structure of calcium oxide, that is CaO, isn't it? So among CaO, who is a metal and who is a non-metal? Calcium is a metal and oxygen is a non-metal. So definitely calcium is the guy who is losing electron and oxygen is the one who is taking those electrons, right? So let us see how our calcium loses an electron. Calcium, atomic number 20, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? So in a simple way, if you want to write 2, 8, 8, 2, right? So is our calcium stable? No, because in the last cell you have only 2. You should have 8 to become stable, isn't it? So how it can become stable? By losing these 2 electrons, right? See here, if you want to understand like which element can lose how many electrons and which element can gain how many electrons, you will only understand that by looking at electronic configuration. So definitely you must know how to write the electronic configuration. So if you want to learn how to write electronic configuration in this form, you have a beautiful trick in our channel. If you go to a description box, you will find the link. Just click the link, have a concept clarity, then come here. Clear? Fine. So it will lose how many electrons? 2 electrons, so that its electronic configuration can be 2, 8, 8, which looks exactly similar to a noble gas called argon. Clear? Fine. So how do you show that losing thing? 2 electrons it will lose and it is no more a calcium now. It becomes an ion, Ca plus 2. See here, if it is losing 2 electrons, plus 2. If it is losing 3 electrons, plus 3. Losing 4 electrons, plus 4. That's how you have to indicate the charge. In case of sodium, I have just shown Na plus. If nothing is there, there is 1. Isn't it? So sodium loses 1 electron. So its charge is Na plus 1. Clear? So here calcium is losing 2 electrons. So it is Ca plus 2. And this particular ion is called cation, right? So in a similar way, who is a non-metal? Oxygen. So oxygen, Atomic number 8, electronic configuration 1s2, 2s2, 2p4, isn't it? So 2, 6 in a simple electronic configuration, right? So outermost shell, you see 6 electrons are there. It is not stable. So how many more electrons are required to become stable? 2 electrons. So this guy will accept 2 electrons. These 2 electrons are accepted by oxygen. So this guy accepts 2 electrons and it is going to become O-2. Okay, and after gaining 2 electrons, then its electronic configuration is 2, 8, which is exactly similar to neon. Now this guy is stable in O-2 form, right? So this is what we called anion. And now in step number 3, what do you show? Ca+2 combines with O-2 and you will get an ionic compound calcium oxide. Okay, so one positive charged guy, when comes near with a negatively charged guy, an attraction creates them and that holds both of them to stay together, right? So this is what we call ionic bond and the compound is called ionic compound, isn't it? And now let us talk about the dot structure of calcium oxide formation. Okay, fine. So we all know how to put the dot structure, right? So first you have to indicate dot structure of calcium. So very simple, we will just put the symbol and we will indicate certain dots. How many dots you will put? It should be equal to the number of electrons in the last shell. For that also you must understand electronic configuration, right? So in the last shell you have 2 electrons, right? So we will put 2 dots. This is the dot structure of calcium. Now dot structure of oxygen. So for oxygen, how many dots you will indicate? 6, because the last shell has 6 electrons, isn't it? So 1, 2, 3, 4, 5, 6. And now electrons are transferring from whom to whom? From calcium to oxygen. How many? 2, right? Show that. So 1 electron transferring and the other electron transfer, show it like this. And so what you will indicate? Ca, it has lost both of its last electrons, that is valence electrons, and it has got Ca+2 charge. And oxygen, along with its 6 electrons, it got 2 more and became stable and it's in a charge -2 state, right? So this is what our calcium oxide dot structure. Clear? CaO, ionic compound. So this is all about the calcium oxide formation. And now let us talk about formation of magnesium chloride. Formation of MgCl2, magnesium chloride. So here, who is a metal and who is a non-metal? Definitely magnesium is a metal and chlorine is a non-metal, isn't it? So metal always loses electrons. So let us check it out. How many electrons this Mg is losing? So how do you know that? By writing its electronic configuration. So what is its electronic configuration? Atomic number 12, guys. So 1s2, 2s2, 2p6, 3s2, isn't it? So in a simple way, if I have to write 2, 8, 2, it's not stable. To become stable, even this guy has to lose 2 electrons, because if it loses 2 electrons, it will have an electronic configuration 2, 8, which is similar to neon, that is noble gas. Clear? So how do you show that losing thing? Say 2 electrons it will lose and it will get a charge Mg+2. So this is our cation, right? And next, who is our anion? Cl. And what is its electronic configuration? 2, 8, 7, right? So is it stable? No. It needs one electron to become stable, isn't it? So one electron it gains and it will become Cl minus. This is our anion. And you see here, Mg has lost 2 electrons, but chlorine, each chlorine takes up 1 electron. We want 2 chlorines, right? So Mg has lost 2 electrons. No, 1 electron is taken up by 1 chlorine, another electron is taken up by another chlorine. You see the formula, 2 chlorines are reacting, right? So how do you show that in a dot structure? Or first you show a normal formation, Mg plus 2 plus 2 Cl minuses will react, guys. 2 Cl minuses. Okay, I have shown gaining with only 1 Cl. Another Cl also in a similar way gains 1 electron and it becomes Cl minus, right? So you will get Mg plus 2, right? I will write 2 Cl's here, okay, minus 1. Each Cl has a charge minus 1. Okay, fine. And now dot structure. Dot structure. How do you show the dot structure of MgCl2? Mg, 2 dots plus 2 Cl's, no? 1 Cl here, another Cl here you can show. Each Cl has how many valence electrons? 7. Show 7 dots. 1, 2, 3, 4, 5, 6, 7. Here also. 1, 2, 3, 4, 5, 6, 7. Right? See, among the 2 electrons of Mg, one is going to 1 Cl, another electron goes to another Cl. So, you will write Mg plus 2, Cl, 1, 2, 3, 4, 5, 6, 7, 8. How many Cl's? 2 Cl's. Okay, minus 1. So, this is the dot structure of MgCl2. Here. So, this is how you have to show the formation of ionic compounds as well as their dot structures. And now, we will study the properties of ionic compounds. So, what is the nature of ionic compounds? How do they behave? What is their nature? What are their characteristics? Everything we discuss. Guys, coming to the properties of ionic compound. So, first and foremost, try to remember here, ions are the constituent particles. Yes or no? Ions are the constituent particles. So, the entire compound is made up of ions only. If you take up like, NaCl, it's like, Na plus and Cl minus ions are present in the whole solid. In the whole solid, you have lots of Na plus and Cl minus ions combined together with a force of attraction. Right? So that's the reason here ions, if you take up a solid amount of NaCl, which are the constituent particles? Ions. Which ions? Na plus ions and Cl minus ions. Right? So that's the reason we say ions are the constituent particles. Okay, in case of ionic compounds. And later, force of attraction is very strong. Force of attraction is very strong, guys. Okay, so what is this force of attraction? What is the name for this attraction? It is called as electrostatic force of attraction. Electrostatic force of attraction. Right? So attraction's name is electrostatic force of attraction, and that attractive force is very, very strong. Like whatever attraction is there between positive and negative, it's very strong. You can't break them so easily. Right? That means you cannot separate Na plus ion from Cl minus ion. They'll be holding very tightly with each other. Together always. You cannot separate them at all, because they have lots of attraction between them. So what is the name of that attraction? Electrostatic force of attraction. Yeah. And they are crystalline solids. Crystalline solids. Say you might have observed the nature of table salt, NaCl, crystally. It's not powdery, isn't it? It is a crystalline solid. Yeah. Next, you know, these ionic compounds are soluble in water. Ionic compounds are soluble in water, right? Say, like if you put them in water, it can dissolve very nicely in water, because you know the water has a ability to break the attractions present in NaCl. Okay, so the moment NaCl goes into water, you know, it will break up into Na plus ion and Cl minus ion. So whatever attractive force that is there between Na and Cl, no, that attractive force can be broken to some extent with the help of water. It has that ability. Okay, so that's the reason ionic compounds are soluble in water, right? Insoluble, they are insoluble in organic solvents. You know, what do you mean by organic solvents, right? Organic in the sense, you know, carbon containing substances. Okay, so all carbon and hydrogens only you have in a substance. Such substances are called organic. So in such substances, ionic compounds are not soluble. They are soluble only in water. Okay, fine. And the next one is in molten state. In molten state or liquid state, ionic compounds conduct electricity. You know why they conduct electricity? Because ions are produced. Okay, in liquid state, only in liquid state, right? Say salt solution is a good conductor of electricity. We have studied this in our basic classes also, right? Say what happens is, the moment NaCl goes into a liquid, I told you Na plus ions and Cl minus ions are separated. So these ions will not stay in one place. They keep moving all over the solution. So when they are moving all over the solution, when you supply certain electricity, it can take that electricity and move, right? So that way we say ions are good conductors of electricity, right? So since ionic compound produces so-called ions, these ions can move from one place to another place. So when you supply electricity, it can carry that electric current from one place to another place also. That's the reason we say, you know, they are the good conductors of electricity, ionic compounds in liquid and molten state. When it is present as a solid form, you know, ions are not free, right? You take a solid NaCl, ions are not free. They are so much tightly held with each other. You cannot separate these ions as long as the compound is in solid form. But once you dissolve it, or once you make it a liquid, then ions can be separated. Once ions are separated, only then these ions can move from one place to another place. Only when they can move from one place to another place, they can conduct electricity, right? So only in a liquid or molten state, these ionic compounds can conduct electricity. Okay, in solid state they will never conduct electricity. So here is a note you must understand very clearly. Okay, in solid state they do not conduct electricity. Why? Because ions are not free. Why? Because ions are not free, right? So this is a very, 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 very important point. One must understand very, very carefully. Yeah. And the last point that you can remember is, these ionic compounds undergo faster reactions. Say whenever ionic compound participates in some chemical reaction, you know that chemical reaction is always very fast, because ions can break very fastly in a solution, and very fastly these ions can combine with one another. With new ions they can combine and a new set of compounds can be formed, right? Ionic reactions are very fast. Say for example, one example of ionic reaction I'll give you. Say NaCl, ionic compound, right? AgNO3, ionic compound. Okay, the moment you add NaCl to AgNO3 solution, within a fraction of seconds, you will get the products, you know, NaNO3 and AgCl. Okay, within a fraction of seconds you get these guys, because what happens is when you take a liquid NaCl, already the ions would have broken, right? You would have got Na plus ion and Cl minus ion. Similarly, this is also ionic compound. When you put it in a water, you would have got Ag plus ion and NO3 minus ion. Okay, so what happens? Na plus ion combines with NO3 quickly, Ag plus combines with the Cl minus quickly. So very quickly exchange of ions takes place and you get entirely a new products which are also ionic. Clear? So that's the reason we say ionic reactions are very faster. So these are some important points that you have to keep it in your mind about the properties of ionic compounds. So with this, I am completing about ionic bond, how ionic bond is formed, certain examples and their properties. So in my next video, let us talk about the next type of a bonding, that is covalent bond, which is also a very important bond. Till then, take care. See you in the next video. And if you like our video, please like, share and subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you.